In this screencast, I will show you how JProfiler's AI probe can help you optimize agentic applications. To avoid vendor lock-in, nearly all such applications use an AI framework. The two most popular ones are LangChain4j and Spring AI, and JProfiler supports both of them. Here, we're looking at the customer support agent example from the LangChain4j examples repository. It uses Spring Boot and deals with customer requests to change bookings. At the heart of the application is an AI service that has a system message, a user message, and chat memory. In typical Spring Boot fashion, the actual implementation is auto-wired from beans in a configuration. Behind the service layer, the configuration configures the chat memory with a token count estimator and a RAG content retriever that contains the terms of use. Tools for the LLM to modify bookings are provided in another annotated bean. These are all the moving parts of the application that are put into play by the integration test that we're going to profile with JProfiler. With the JProfiler IDE integration, this is really easy. There are two settings that we should adjust before the test is actually started. First, we choose a recording profile that records CPU data as well as data for the HTTP client and the AI probes. Second, we need to ensure that after the test finishes, we automatically save a snapshot and open it in JProfiler. Otherwise, we would lose the profiling data when the JVM exits. Let's run the test and record data. Probes in JProfiler display live data, so we can switch to the AI probe right away to observe the recording. The test is going to run for about 50 seconds. In the telemetries, you can see that there are two distinct types of LLM interactions, chats and embeddings. For each of these, there are telemetries for the request count, the average chat durations, and chat tokens, divided into stacked areas for input and output tokens. Probe telemetries can be added to the probe telemetries overview to compare them with all other telemetries. The test has now been completed and a temporary snapshot has been opened. To make it permanent, we can save it to a JProfiler snapshot file. With all data recorded, let's look at the heart of the AI probe, the events view. Here, each LLM interaction is represented as one row in a table. You can see the event type on each row, which is either a chat request or an embedding. The description column contains the model name for the request. This description serves as the default aggregation level for the hotspots view. Another screencast will show how to customize hotspots for individual use cases. What stands out visually in the AI probe is the instructions column. The complete set of input tokens for a request to an LLM is typically large and starts with similar verbiage, so it would not be useful to display a part of it here. Instead, JProfiler shows statistics on the type of messages in the prompt. The distinct icons represent the breakdown of the prompt. This prompt consists of one system message, two user messages, three assistant messages, and finally, two tool messages. We can see the exact sequence of messages with their complete text by clicking on the hover button. You can search for text messages or copy everything to the clipboard. As you scroll down, the drop-down at the top provides the context of the currently displayed message. Also, you can jump to any message directly. The dialog is non-modal and updates dynamically as you click on different rows in the table. Events have stack traces, so you can tie them to your own code. When you select more than one event at the same time, the selections view shows you cumulated statistics. You can use other metrics, like input tokens, as the primary metric to see exactly which code paths are consuming the most resources. The events view allows you to filter the displayed events across multiple dimensions. Most conveniently, you can use the lower views to do so. For example, in the timeline view, you can select the time range to restrict the displayed events. The other analyses are now filtered accordingly as well, and we can add additional filter steps. Histograms for input tokens and output tokens are also available. You can also filter by example to isolate outliers. Remember that we not only recorded the AI probe, but also the HTTP client probe, so we can go one layer deeper and inspect the actual communication with the remote LLM. The probe call tree shows the HTTP call durations of the different test methods, while the hotspots reveal the distribution for the different endpoints. Armed with these tools for drilling down into specific problem areas, you can analyze resource usage patterns and identify bottlenecks that are otherwise blurred in cumulative statistics or unrecognizable in individually logged data.